In this video, I wanted to do another problem involving applications of systems of equations. This is a motion problem. So in this problem, we need to know one formula, which is the distance formula. So the distance formula says the distance traveled is equal to the rate times the time traveled. All right. We can also rewrite this equation the following way. We can also write it as rate is equal to distance divided by time, or distance over time. And that's pretty simple to get, right? We would just need to divide these two sides by t, and that's how we get it, because the t's here cancel out. We get r is equal to d over t. That's what we have here. All right. So let's read the problem. So the problem here says, a kayak can travel 45 miles downstream in 3 hours, while it would take 15 hours to make the same trip upstream. Find the speed of the kayak in still water, as well as the speed of the current. All right, so with these type of problems, it's always useful to draw a diagram. So downstream and upstream. So while going downstream, here's the kayak. The kayak is, its rate is this way. Let's call it K. So the rate of the kayak, the speed of the kayak is going that way. And while it's going downstream, it's going with the current. Let's represent that with a C. So the speed of the kayak plus the speed of the current is the speed of the downstream. That's why it takes only 3 hours. And when it's going upstream, it takes a lot longer. It takes 15 hours. So let's see why that's true. So when it's going upstream, the kayak is pushing this way, and the current is pushing against the kayak. So you can think of the total, or the net speed for the downstream, you can think of it as K plus C. And the upstream is K minus C. All right. So once we have that, it's very important to be organized with these type of problems. So organize like this. We're going to consider what distance we have for each of the scenario, what the rate is, and what the time is. All right, so I'm just going to move this over just a little bit. And this is downstream. I'm just going to put down, and this is upstream. And let's draw a line that separates that, like that. So going downstream, the distance was, let's see, the distance is the same for going upstream and downstream, so 45 and 45. The rate for going downstream, we said, was K plus C, and the rate for going upstream was K minus C. And the time that it took going downstream was 3 hours. The time for upstream was 15 hours. So we have 3 and 15. So here's what we have. We have that the rate of the downstream is K plus C, but using the formula here, rate is also equal to distance over time. That's 45 over 3. We've got the following. We have K plus C is equal to 45 over 3. And the other equation we have is K minus C is equal to the rate, but the rate is also equal to distance over time. That's 45 over 15. So here's what we have as well. We have K minus C is equal to 45 divided by 15. So let's simplify the right side here to see what we have. So I'm just going to put arrows to indicate that we're moving that way. So K plus C is equal to 15. And then with the second equation, it simplifies to K minus C is equal to 3. So what we have here is, with these two equations and these two equations, these are just a simplification of, this was simplified to get this, is we have a system of equation. And you'll notice that, let me write this just a little bit better. These are in standard form, and we have opposite coefficients here, which means that if we use the addition method to solve, so we add the two equations, what's going to happen is the c's are going to cancel out. So if we add, we get the following. So we get k plus k gives us 2k, and then c plus c minus c cancels out, is equal to 15 plus 3 is 18. All right, so we can then solve for k by dividing by 2. So it cancels out, we get k is equal to 9 miles per hour. What does k represent? K represents the kayak in still water. And then again, C represents the current. So once we get this answer, the speed of the kayak, we can then plug it into either the first equation or the second equation. It doesn't matter, to solve for C. So let's say we plug it into the first equation. So we would get the following. So this is solving C. So we'd get 9 plus C is equal to 15. And let's see, subtract 9 from both sides to solve for C. We get that C is equal to 6 miles per hour. So the speed of the kayak is 9 miles per hour. The speed of the current is 6 miles per hour. All right. So if you have any questions, feel free to ask me. Otherwise, hopefully this all made sense to you guys.